In today's video, I wanted to show you how you could create a scene like this. So basically it's a particle simulation colliding with a terrain with the height field. You get this nice swirly force here, nice particles. So we're gonna start off by creating a terrain itself, then we're gonna do a particle simulation, and then we're gonna render this scene using Houdini and Redshift. Also, if you wanna grab a final scene file for this shot, you can do it from my Boosty. A link is going to be in the description. Let's start this off by creating the height field node. So geocontainer, height field. In here I'm gonna just set this grid spacing to 1.5. Let's create a sphere for masking. I'm gonna set the size to 300 and then the radius to 0.9, and I'm gonna create a node called mask by geometry, and I'm gonna mask this height field by this sphere. So you get something like this. I'm gonna increase the blue radius to 300, and I'm gonna use a height field noise to distort our plane. So first thing what I'm gonna take off the center noise. Let's set the amplitude to 350 and then the element size to 100. The noise type I used a Perlin flow. I tick the fold on and also just offset this noise a little bit, and also use the warping here, so something like this. And actually let's increase a little bit the element size so we get something like this. To distort this up a little bit, I used HeightField distort by noise, and then the settings something like this. So we're just distorting this node, breaking the shape up a little bit, and also I used a HeightField resample node. So basically I increased the resolution 5 times here to have more quality when we're gonna use a erode node. So before we use erode node, let's create a mask by feature node. Actually it's called HeightField mask by feature. Okay, and then I'm gonna mask this by, and then we can just dial this up a little bit, something like this. Let's create HeightField erode node, and we're gonna use this mask to the second input and then the erode node to the first input. Okay, and if you just scrub to timeline a little bit, as you can see, it erodes each frame. I'm gonna use this freeze add frame function. And also let's turn this materials on. We wanna turn off the visualization here, and then let's tick this box on. It's gonna take some time because we set a lot of resolutions here. Okay, so after the erosion, as you can see, you get this a lot of nice details here. You can lower down this resolution or lower up. I found this resolution of 5 works just fine for me. Let's again use HeightField noise, and let's just noise this erosion just a little bit, and also I'm gonna use this mask. So let's set this like this, and then also let's set this to warping a little bit, and as you can see we just get this a little bit of breaking up the shape again. And also I'm gonna just duplicate this distort by noise, and then I'm gonna use this here. Just lower down the amplitude and lower down the frequency. Let's use HeightField transform, because at this size our HeightField is extremely large. So I'm gonna just lower this 100 times, as you can see here, and also I'm gonna just offset this a little bit from the ground, as you can see, something like this. This is going to be our height field. Let's call this height field. What you can do as well is you can use a file cache node, turn off these options, and then just use cache height field. So each time you open the scene, you don't have to re-erode your height field. It's just going to be saved in the disk here. After we saved our height field, first thing you need to do is you need to take convert height field node. Let's connect this up, and then what's gonna happen is it's gonna be converted to polygons here. As you can see, is we need to lower down this density to have less polygons. Let's turn off the UV. Okay, so after you lower down the resolution, this is what you get. And what you need to do here is you need to clean up those attributes that you have here. Let's use a clean node, and then we're just gonna keep the height attribute here, and that's it. Next step what we need to do is we need to normalize this attribute, because at this moment it's basically from 0.07 to 1.3. We need to just normalize this to 1, 0 and 1, and we can use a clip node to source particles from. So basically what I'm going to do is we're going to use this clip attribute height. And what you have here, if you put down the 1 here, basically it's like fully clipped, and then if you just lower down this value, as you can see, it reveals this nicely. So this is exactly what we need. We can animate this using keyframes, or we can use an expression So I'm going to use expression. So basically I'm going to remap from 1 to frame 96, and my clip is going to be from 0.9 to 0.25. If I hit play, as you can see, this is what's gonna happen. It's slowly gonna reveal this terrain and more particles are gonna be emitted here. Also, one more thing, if you template this convert height field node, as you can see, it's the same in terms of collisions. Basically, when the points are gonna be born here, the problem that we're gonna have is some points are gonna be born inside of the terrain and they are not gonna collide with it. So what we need to do is you need to use just a pick node here and then just pick this just a little bit here, as you can see, like that. And also we're gonna use pop grains later down the line. So we're gonna use attribute create node here, and let's set the p scale. For me it was 0.005, and also we're gonna use a rest node. We're gonna use this to create this nice color gradient on our particles. Also we're gonna use a height field resample node. We're gonna use initial height field as a volume collision for our particles. So we're gonna use height field resample to just lower down the resolution just a little bit, because we don't want all of these details here. We just want our simulation to run a little bit faster. Next up, we're gonna set up the forces that we're gonna use in this simulation, and for that I'm gonna use a subdivision node here. Basically, if you take our height field, as we know that it doesn't really have much polygons here, so that's why I'm just gonna subdivide this one time just to have more resolution for particles to sample the velocity from, if it makes sense. Since we have the height here, as you can see, we can actually take this from clean node and then do this like that. And here we could just use a measure node. If you press right mouse button, you can use this spreadsheet here just to have spreadsheet on selected node. I set this as a shortcut for myself, so if I press Alt S, I'm gonna have this spreadsheet, and as you can see, this is our height. What I want to do, I want to just invert this, so I'm gonna use attribute adjust float, and then if you take, I want to have p scale, of course. I want to have a height, and what I want to do is I want to just invert this, so I'm gonna just multiply this by -1. So I just inverted the height, and I'm gonna use a measure node to basically set this to element, to points. Then I'm gonna just calculate a gradient of this height. Okay, and then I'm gonna save this to attribute called, as you can see here, gradient. You can actually visualize this as well. You can just press this gradient button, and then if you go to the visualization here, press right mouse button, and then you can switch this to mark. Okay, and then in here just use vector trail, and you want to see these vectors. So basically, if you look at this, as you can see, it's pointing up to the hills, up to the higher points, and then you get this kind of a gradient. You can just increase this and just see yourself. Basically, it just kind of nicely follows the curvature of geometry and points to the, which is exactly what we need. But what I'm gonna do is we're gonna basically swirl this around using a cross product. So we're gonna take our normal, and we're gonna use cross product, connect this to the second input, and we're gonna take our bind and take our gradient here, gradient vector, which is this one, and I'm gonna cross this with the normal. And if you use a bind export here, just connect this, and then I'm gonna output this to gradient. Okay, and as you can see, it's changed. And now if you look at this, it actually creates this, for example, here. Let's also normalize this so we can, and then we need to adjust this a little bit, so just length scale, just lower down this, and as you can see, it creates this nice swirls, and our particles gonna take this velocity and apply to themselves, and they're gonna just nicely swirl around the terrain. So this is our force, actually, the gradient force. That's done. And then the third thing that we need to do is we need some sort of a bounce for our particles. So we're gonna have one collision, which is going to be the terrain itself, And then the other collision is going to be those bounds here. We're gonna create this using bound node. We're gonna take this from the clean node here, and then as you can see, we get this box around our terrain. And then if you use a blast node, you can just take this top polygon and then just delete it, and then use a poly extrude node to just have a thickness here. So let's put this 0.01 or actually 0.1, and then turn on this output back, and let's create a pop network and let's connect this. So particle source going to be first input, second input is our height field terrain here, the third input are force or gradient force. Let's, by the way, turn off the visualization here. And then the fourth input is going to be our bounce collision here. So this is what we get. And let's call this, for example, pop grain sim. Let's dive inside the pop network. Delete this merge. We want to set up the pop source first of all. Gather on surface. Let's turn on the relax iteration, and let's turn on the scale point count by area. Let's set this to something like this. Basically what it's gonna do, you have this constant birth rate here, and what's gonna happen is that this value is gonna be scaled by this reference area. So lower this value is, the more particle is gonna be born in this reference area, if it makes sense. Let's go to the birth tab, and let's switch this to negative, and then also let's create the pop wind here for basic force. We're gonna have amplitude of 0.5 and then sphere size of 2, and also let's increase the pulse length here, and let's create a pop drag, and it's gonna be default settings. Next step, let's bring in our collisions. We're gonna start off by terrain object. We're gonna just put this simple expression here, op input path, and then like this, and then basically the number that we put here is the number of incoming input. So if you put 0, it's gonna be input 1, 1 is gonna be input 2, and so on. Let's put this to basically 1 because we need the second input. As you remember, our terrain comes to the second input, and also we're gonna turn on this use height field option here. And for settings, I set the bound to 0.2 and then the friction to 0. Let's use a merge node, and then also let's bring in the fourth input, which is this walls here that we used. Let's copy the expression. Let's put this here, and then of course the fourth input is gonna be on number 3. If you middle click on the subpath, you can actually check if you have anything that it's incoming. So as you can see here, object geo1 poly extrude 1, which is this exact node here. Let's connect this up as well, and then in the collision tab I'm gonna use a surface collision. Let's create another merge. Let's connect this like this, and then also what we're gonna do is we're gonna use a gravity force here, something like this. If you actually press play here, you can just turn off these. Actually you need to turn off this like this, just basically the visibility here, and then also let's turn off the visibility of source geometry here. And if you hit play, this is what you get. As you can see, everything is working, and of course the only thing that we're missing here is actually a pop grains interaction here. And then pop grains, let's create them, let's connect them to the second input, and then let's just turn off the friction. So I didn't want any friction, so I just turn this off. And then the important part here is you need a lot of sub-steps in order to pop grains work correctly. Remember, you set it up this p-scale here, so this p-scale is going to be used by the pop grains as a particle size here. At this moment you can't really see them, but if you click on this button, right mouse click on this, you can turn off the spheres visualization, and this is basically your particle size here. And if you hit play, you can see they got some basically interaction, but it's very, if you turn off this real-time playback, it's very like jittery kinda. In my case I used 8 sub-steps here. You can go a little bit lower, but I just used 8 here. It's going to be a lot slower, of course, as you can see here, but you're gonna get more nicer result, more smoother result. And the next step you need to do is you need to use a pop node, and with this pop node we're gonna basically bring in our terrain force that we had in the third input here. In the inputs, let's use a third context geometry, which is this one. And inside, just simple setup here. We're just gonna sample this third input using nearest particle position, and from this nearest particle position we're gonna bring in from this terrain geometry our gradient force. As you remember here, we outputted the gradient, so bring this in, and then let's add this to our force. So just use an add node and then connect this up, and also I'm gonna just multiply this by 5 here. Let's go back, and then this is basically our particle simulation. In this DOP network pop sim node, in here in the object tab, we're just gonna use pop star, and if you just simulate like 25 frames, you can just check this. As you can see, it's fine, it's working. So you can just use this HeightField as just a mask, and as you can see, you have this very nice grain simulation. And of course we need to cache out the rest of our frames, so we're gonna use, first of all, we're gonna delete everything that we don't want to have in terms of attributes, because there is a lot of them. We only want to keep age, life, rest, p-scale, and then the velocity here. Choose a file cache, and in my case, what I did was I simulated only 100 and then around 65 frames, because the simulation become very slow. But on my machine it took about like 25 minutes to cache. As I said, you can just lower down the sub steps, or you could just lower down, or actually put these higher values here to have less particles. But I think 25 frames for this kind of simulation, it's fine, because you don't get almost no like intersection between grains. You don't have any type of flickering in the simulation, so you get really nice high-res simulation out of this. So let's cache this out. I'm going to use explicit path, and then I'm going to save this to my D caches folder here. Let's call this $S and $F3 .bgo .sc. You can basically leave this by default. You don't have to like explicit path here. I just don't want this to be saved on my SSD, because the file size is going to be quite a lot. I'm just gonna save this to my, let's hit the save to disk button. After the caching is done, the next step what I did was I used a retime node to basically slow down my simulation at the specific frame. So what you need to do is you need to just press this post extend, and then you can just animate the speed however you want. So for me, what I did was from frame 75 to frame 125, I just slowed down this to 0.4, and then I just set this to more linear curve here. So if you press shift on the speed, you can bring up the animation editor, and then you can select these here and then adjust them as you wish. Next important thing is attribute adjust color. Remember we did here rest position here, so we're gonna use this rest position to have a noise. This location attributes should be the rest, and as you can see, you get this really nice color gradients here, and you can set up this color ramp however you want. In my case, what I did was, first of all, I set this to grayscale. In here I used just a kind of white color here, and then here I used more cyanish color, and then more dark blue like this, and then the last two, they're going to be just black like this. And then you can adjust the element size to get the effect that you want, and also in the fractal tab here you can just lower down the roughness to have less detailed gradient here. Of course you can adjust this as you want. You can play around with the different ramp and stuff like that. Also what I want, if you look at this, the particle size is the same at the beginning, when the particles are born. What I'm gonna do is the similar thing that I did in the previous tutorial, basically the same thing here. I'm gonna take age, fit this age with the life. I'm not gonna explain this because I already did many times in my previous tutorials. Basically, when the particle is born, we're just gonna slowly appear this. Let's fit this value, choose maybe 0.1, and then let's bring in the p-scale and actually multiply this p-scale by our values, And then let's use bind export node to export p-scale. And as you can see, if you just scrub through timeline, the particles are gonna slowly appear. And this fall off you can adjust in this second fit range. So basically, if you put this here to 1, as you can see, they're slowly appearing, but I want this to happen a little bit quicker. So I'm gonna put down the 0.1 here. And that's pretty much it. In order to set up Redshift rendering, we of course want to somehow render this HeightField as well. So I'm gonna use convert HeightField, and then I'm gonna say I'm not gonna change any settings here because I do want to preserve all of this geometry. But as you can see, the point count is 11 billions. And of course, if you can't render this amount of polygons, in my case I can, because there is nothing else than particles and then the height field in my scene. But you have other stuff. You could use, for example, poly reduce to reduce the amount of polygons and also to save the the details here. Or you could use something like a bake maps baker to bake the normals to higher res geometry. Or you can, as I said, just lower down this density and it should be fine as well. But in my case, as I said, I just use this original quality here. Let's create a null as well, and let's call this out terrain. Okay, and let's turn this off and let's call this something like setup, for example. And then let's create 3 geometry nodes. First of all is render particles. Second one is render terrain. And the third one is just the grid. So in the grid, let's create a grid. Let's increase the size. And also what I did was I just projected the UVs here. So I get this type of UVs. Inside of the terrain, let's create object merge and let's reference to our setup here. And then let's choose the terrain object. Here's our terrain. This is exactly what we need. And then the particles also use object merge and then merge in the particles here. Let's create a camera and then let's of course set up the camera. So let's create camera object. Let's dive inside and let's just choose some nice angle. I'm gonna adjust the focal length, maybe something like this. And also I had the animation was done with using just a null. If you select the camera and then say keep position when parenting and then just parent this null, you could just use this to just orbit around this object if you want, of course. In my case I had, like as I said, 3 cameras and I just switch them between them when I want to. So we had a camera, we have a render objects, and then let's just go to the frame 50 for example, and let's try to fire up Redshift. So Redshift, open render view, and let's just hit play. So by default we get this. I'm gonna set this to original size. I'm gonna create a dome light here, and let's rename this to HDRI, and then in here to the texture I'm gonna load my HDRI. So I used a Grayscale Gorilla HDRI, Creative Spaces 04. You can use whatever you want. And then as you can see, it comes with this strange orange color. So what I did was I just turned down the saturation here and then lowered down the intensity. And that's pretty much it. Let's assign the materials. So let's create a material builder. I'm gonna create 3 of them. First thing, of course, is particles, terrain, and then the grid. And let's go back to our terrain. By the way, I'm switching between the networks. So basically this is my object network, right? And then if you press this button here in this area, you can switch back to material network, and then in this material network you actually create your materials. So I had this basically assigned to the shortcuts. So if I press 2, I get the object network, 3, I get to the render network, and then 1, this is material network. So basically what I'm doing, I'm just switching between these places here. Let's assign the materials. So we're gonna select particles, assign to particles, select the terrain, assign to terrain. Okay, and then the grid, of course, let's assign the grid material here. In the original scene for the grid, I had a concrete texture, nothing too fancy, but for this, I'm not gonna recreate this. It was just simple concrete texture. And then for terrain, what I had was I had a white color here, and then lower down the reflections and then just decrease a little bit the roughness of reflection. So this is basically material that I had. We can see the particles at this moment because we have to select here Redshift object and then say render object as particles. And then if you reload the scene, you can actually see that you got all these nice particles here, you can see. And then the material for them, as you can see, it's quite dark in this example. And then if you're using the latest Redshift version, which I am, the problem with this is that in the progressive mode, which we're currently in, you can't really see the bounce lights from the particles, which is really annoying. So I think it's a bug. I don't think it was before there, but if you put this bucket mode and if you render this as a bucket, as you can see, our image is going to be a little bit brighter because now we're actually having some bounce light in those particles. As you can see, it's a little bit brighter. We're gonna create a point attribute node, and by default it's color. So we're gonna just take these colors and transfer this to the base color here. And then again, hit reload button. And as you can see, you're kind of getting something here, but they are still like quite dark. So let's hit the bucket render mode. And as you can see, they are brighter. You can really see the colors now. If you put down the snapshot here and just turn off the buckets again, as you can see, like there's quite a difference because with the progressive mode, we don't really have a bounce light for the particles. As I said, it's a bug. Can't really do anything about it. I had to work with this myself. Also, what I did was I used a color correction a little bit gamma up and then saturation a little bit up as well. You can also shift the hue for these particles. In terms of shader for the particles, I lowered down the roughness a little bit, and then what I did was to have them be more shiny looking. I also used a coating and with the little bit of roughness here. That's pretty much it for the particle shader. And then the last thing for this render, I used a redshift light here. I had settings like this for this light, so I have this long light here, and then just lower down the intensity of this light, and then also lower down the spread here. And then if you press here look through light, you can actually tick this, just art direct those lights however you want. I had something like this going on for this scene, so I had basically light coming from the side of this, and this was basically my light. So I had one HDRI and I had one side light here. And also let's just a little bit decrease the brightness of the grid here and hit bucket render mode. And as you can see, the render is done. I think it looks pretty cool. Also, let's scrub to timeline a little bit more. So let's say 125, where you can see more particles here. And then let's hit render as well. Let's see how it looks. You have this really nice terrain. Let's set up some other cameras. So for example, you can duplicate this camera. You can set up some, for example, close-up shows, right? So let's increase the focal length. And for example, you could go ahead and then find really nice angle like this, for example. And then if you want to, you could also create one more camera. And then for example, this camera is going to be from the top. So let's reset this. And then we can't really see it here, but it's actually there, as you can see. If you just take the x-axis, just minus 90 degrees, and then let's say we're gonna look to this camera, up the y position of this camera, and let's increase it a little bit more. Maybe something like, so basically this is going to be top camera, this is going to be close up, and this is just the main camera, right? And what you can do is you can create a render switcher here and connect them up like this, and then you can view the switcher itself here. When you need, you can just keyframe this and then you can switch between them. That's how I did actually this switching. Before that, also what you can do, if you fire up render view, you can press this button and then choose, for example, close-up camera here. As I said, it looks dark. It's really sad that this bug exists here, but I already said that it's a bug. I hope they want to fix it, but for now we have to work with this. Let's enable the bokeh and then let's pick some place here, for example. And then if you lower down this aperture, you're gonna get more bokeh in your image. And then if you render this again, And as you can see, you get this type of image, get this really nice bokeh. I mean, you can find whatever angle you want. It doesn't really matter like which type of render you do, right? Because it all depends on the like choices that we make. For now, I'm just gonna stick with the main camera, and then let's do this final bucket render here. While it's actually doing the bucket render, what we could do is we could set up this redshift drop here. So the main problem with this is most of people, of course, if it's like a personal work, they want to output just the PNGs, right? So you can select PNG, you can select the 16-bit, and then in here, I just like to remove this hip name from the file, and I'm gonna just call this, for example, particles render, and then let's change the extension to PNG. If you render this like this, the colors not be the correct ones, because what's happening there is we're viewing this image with the ACES color space, right? And if you render this color space will exist on the PNG as well. But what we want to do is we want to bake this color space. So if I just, for example, show you, if I hit this render to disk button, it's gonna fire up this mplay, let it render. So here's our image. Okay, so look, basically this is the image in the mplay view, and this is the image like I'm seeing through my file explorer, right? The colors look off, something is not right. So what you need to do in order to have correct PNGs, just go to post effects, you just turn off all of those options. So you're gonna just bake in the color. And also in the mplay preview, you could just put here 1 just to display a gamma. And then if you hit render to disk button, what's gonna happen is it's not gonna look correct in the mplay. Wait a minute. As you can see, after the render, it doesn't look correct. So the previous render looks correct, but this one is not. But it's actually correct, because if you take this image, for example, right, this frame that we just rendered, as you can see, it looks the same. But I'm actually viewing this frame here to my to this DGV view. It doesn't really match. It can be just default Windows viewer as well. But the thing is happening that we're viewing this through a ACES color space, and if you press this little dock button here, you can just turn off the ACES open color, and then it's gonna look the same. So basically, when you're rendering PNGs to disk, you just have to turn off these options. This is optional, by the way. You don't have to do this, but if you want to look correct in the mplay as well, you can turn this off. And the last thing, of course, if you go to the advanced, you can turn on the motion blur here, switch this to movie, and I just lower down this angle a little bit, and that's pretty much it. And of course, if you want to have different cameras here, you can select them as well. So let's render with the motion blur enabled. I'm gonna see how it's gonna look. So yeah, it's almost finished, and yeah, it looks kind of nice with motion blur and stuff. That's pretty much it, guys. I know this is not the best lighting setup. I had this in my scene, I had this more dialed down version, and as I said, you can get this from my final file from my Boosty, but this is like what I used in my shot. I just a little bit dialed this down, but the shaders and everything else is the same, of course. So yeah, guys, thanks for watching. See you guys in the another video.